Recording in progress.
Okay, we now have over 1,000 participants who have joined. So please, I'm pleased to introduce to you Dr. Jisui Dong, Unit Head of the Local Production and Assistance Unit. Dr. Dong, if you please.
Thank you. Thank you, David. And hello, everyone. Today, we begin the second week of the Water CGMP Training Marathon, organized by the Local Production and Assistance Unit. It is a great pleasure to see you with us. As today, we move into the third session on the basis for a sound environmental monitoring program in vaccine manufacturing. A whole series of coordinated measures involving all parts of a production, factory design, personal training, and more are needed to control and reduce contamination, which we know as contamination control strategy. Today, we will look deeper the central role that environmental monitoring plays in this strategy and the benefits of such monitoring in vaccine manufacturing. The speaker we have today is Mr. Alan Kupferman. If anyone you are not familiar with Alan, I would like to introduce him to you. Alan has over 40 years of experience in the pharmaceutical, vaccine, and biological industry in the areas of GMP, designing facilities, and conceptual studies for production units. So without further ado, Alan, the floor is yours. Thank you all.
So
Yes.
Alan, before we begin, let us launch the poll before your presentation.
Okay.
Will that be okay?
Yes,
It
yes,
should
sure.
only just take a few minutes. So if we can launch the poll now, it will give opportunity for all the participants to enter their selections, and then we can begin with the presentation. I see that it has now been launched. If you're not able to see it, perhaps you need to wait 1 to 2 seconds, but otherwise you can select the poll function on your platform on your device to activate it. There are 3 quick questions, and scroll through to answer all 3 of them before you submit. So we'll just leave it open for a few minutes, a couple minutes, to allow people to enter the selections. Okay, we'll just have the poll on for another 30 seconds. Okay, we will now end the poll. And so, Alan, if you can start, and also please turn on your video camera. Thank you very much.
I cannot turn on because the host has stopped it. Okay. Okay, can you see me?
Yes, we can see you.
Okay.
Yes, thank you very much.
So good morning or good afternoon, wherever you are. Many thanks again for WHO for taking me again as a speaker on the marathon. And we will go immediately into the topics. So the topic of today is to look for basis for a sound environmental monitoring program in vaccine manufacturing. Now, what I must say also from the beginning, is that many points apply also to conventional pharmaceuticals. It's not only for vaccine manufacturing. Of course, I will speak about what is the difference between vaccines and between conventional products, non-vaccines, but many of the points apply in general to any pharmaceutical industry. So we will look in sequence at what is a contamination control strategy, because how do we go at it? Then I will explain you the difference between vaccine and drugs. We have to look also what is classification monitoring, because that is often confused. What do we understand under environmental monitoring? What kind of methods do we use? And also one point which is very important for vaccines is also the fact that vaccines are temperature sensitive products. So we look a little bit also at temperature monitoring. And then to round up the presentation, we will look at two small case studies. Let's start with what is a contamination control strategy. In fact, I would like to
excuse me, Alan.
Yes?
Excuse me, I'm sorry to interrupt, but could you share your screen and share your presentation slides? Could you please share your screen?
It's not
with your
sharing?
presentation?
Yes, sorry. Okay.
Perfect. Just now.
Okay, apologize. So, okay, just I go back. So this will be the program, what is contamination control strategy, what are different between vaccines and other drugs, what is classification, what is monitoring, what's the difference, what do we understand the environmental monitoring, what are methods that we are going to use. One special topic is temperature monitoring and then the case studies. Okay, so let's start first with the contamination control strategy. And you may be aware that the European Commission has published the long-awaited revision of the Annex 1 of the manufacture of the sterile medicinal products. In fact, this is something that we have been waiting for over 10 years. There have been many drafts, but now we have the final version. And one of the very essential points is that to produce sterile medicine, we need quality risk management. And Annex 1 now explains what are those specific and requirements, and it explains them in detail. So we want to ensure that we have a contamination control so that we know what kind of contamination we have. We have to know how we fight it. We have to know how we monitor how successful we are. And that is explained also with an approach and a level of details which are adapted to the type of process and product, because you understand that if you have a product, different steps of a product have different risk. If you have a packaged product, of course, maybe the temperature is essential, not the particles anymore. So that means that this requires from you to know well use the specificity of your process and your product. And what we want to achieve is the sterility assurance. And you know also the notion of sterility assurance. Sterility is not an absolute term. You cannot be sure that 100% of the product is sterile, but we have what we call sterility assurance, which is defined that we may have 1 in 1 million products which is not sterile. That is the sterility assurance. We want to have also what a bioburden control, and a low bioburden, of course, because if we have from the beginning a low amount of bacteria, contaminants in our product, the chance to have a sterile product increases. We want also to have a product which is pyrogen or endotoxin free. And of course, we do not want to have foreign particulate matter. So to achieve this, we have a lot of measures, and this is what they call in the Annex 1 as contamination control strategy. So this is again here you see the reference, and I can advise anyone who has not yet read it to download it very quickly and to study it in detail. So the Annex 1 says that the contamination control strategy should be implemented across the facility in order to define all critical control points. So that means you have to know where something could happen and to assess the effectiveness of all the controls. That means we have to define something and you have to see how successful we are. And the controls can be, how do we design the factory? What procedures we have? That means our SOPs, the technical, or our machines, what is the equipment that we have? Organization, QA, QC, calibration, etc. Do we have all this? And of course, we have controls and you have monitoring. And that, with these controls and this monitoring, we manage the risk to medicinal products, quality and safety. And of course, this strategy, this combined strategy, should establish what they call a robust assurance of contamination prevention. There should be no gaps, it should be safe. So the contamination control and steps taken to minimize the risk of contamination from microbial, endotoxin, pyrogen, particle source include a series of interrelated events and measures. So that is also, there is no things that I do, someone does here, particle control, someone does a microbial control. It's all interrelated because you know particles bring microorganisms. And we say that the 5-micron particle is the taxi for the microorganism, etc. If we don't have a good differential pressure, we may have ingress of contaminated air. So you see, it's all interrelated. So, of course, to measure those, to assess them, to control and monitor them, we have individual instrumentation. We have building management system, we have different measuring instruments, but we have to assess the collective effectiveness together. It's only that. So that means also when the quality assurance will release the product, release, or let's say examine the product batch record, and before releasing, he will also consider all those other things about the contamination, etc. So it is collective effectiveness that you are looking for. And of course, to do that, we need detailed